to number 6. Let's go ahead and check this out. So when you're looking at these, you are looking at how you are getting your people that you are testing, and then how it is that you're splitting up that group. So in this one here, we recruited 800 students with the flu who were volunteered by their parents to try a new flu medication. So this isn't really random in terms of how you got the people, because they already had the flu, and they were recruited by a doctor. So it wasn't just random picking of people who want to and don't want to, things like that. So it's not random, which means that the selection was not random, which also means that whatever you figure out doesn't apply to all of the people. It really would just apply to the people that you're talking about. So then the people who were picked were then randomly divided into 2 groups. Half of them received it, half of them didn't, and you found out some information that it seemed to work a little bit better, 4 versus 8 days. So the allocation was random, so we can infer that it was cause and effect. It does seem to be that the medication is doing something, but we can't make inferences to our general population. So again, cause and effect seems to be true, but it is only for the people in this particular study. All right, this one is a quickie. So for this one here, this is all of our data, and we're trying to figure out which measure of center. Remember, there's 3 measures of center: mean, median, and mode. So this one here is skewed left, meaning most of the data is on the right, but you have a couple pieces over here that are skewing the mean over in this direction, which means that we don't want to use the mean. What we want to use anytime it is skewed is the median. So that way these don't really bring anything down, they just count as evenly posted in between there. All right, here's a good one. So let's see. The water balloon manufacturer claims that its balloons hold an average of 8, so that's 8 is our X bar, standard deviation of 0.7, and the distribution of water is normal. What percentage of balloons holds at least 7 ounces of water? So let's make our little chart. Here is our 8, here's 7. So if I want at least 7, that's not 6. 6 is too small, 5 is too small, etc. I want this information over here. So ultimately, when I get my answer, I want to have that. Now, when you look up things in your Z table, that's not the information that you get. You always get this stuff over here. So we will need to subtract when we're done. So the first thing I need to do is actually figure out what is my Z score. And the data minus the average divided by the standard deviation is how we do that. So this is our Z table. And when I look this up in my table at negative 1.43, so negative 1.43, I do get this percent, which is 7.64%. But that is the percentage that have less than 7 ounces of water. I want to know the percentage that has more than 7 ounces of water. So what I need to do is I need to subtract this from 100%, which gives me 92.36%. All right.